Welcome aboard, everybody, to our, I almost said Christmas meeting, but our December meeting. And tonight, I thought I'd talk a little bit about introduction to GNU Radio. Now, I did put this one together quite some time ago and then worked on it off and on and off and on. So I'm already setting you guys up for, if I make a mistake, it's because it's been a while since I've really reviewed it. But anyway, it's more intent to be an introduction, just to kind of get the juices flowing, and then I think as we get going into 2026, we can maybe talk about a little bit more fine details of what it's all about. Oh, wait a minute. All right, we can see that?
Yep.
Okay.
Yep. Gonna close my...
Peter, do we need to do the preamble?
Oh, sure. Geez, I don't have it written down there. Where's Ken when you need him? I guess just to notify everybody that we record our meetings and we make them available on our YouTube channel to the general public. So by participating in the meeting, we take it implies that you have agreed to those conditions. Is that okay, Al? Okay. Introduction to GNU Radio. Someone want to mute the mic? Can someone mute the mic? Can someone see where that's coming from? Okay. All right. So GNU Radio, it is a free and open source software development toolkit. It provides signal processing blocks that can be linked together in a visual programming environment called GNU Radio Companion, or GRC for short. And this will allow users to develop real-world radio systems using readily available hardware or as a simulation tool. Benefits of it is, rapid prototyping for DSP and RF work, hardware agnostic, same design will work with different radios or different hardware. There's also a large community out there for resources and help. So GNU Radio works by connecting signal processing blocks into a data flow graph that performs radio operations such as filtering, demodulating, and transmitting using a combination of Python for high-level control and C++ for high-performance processing. Now, example here, we are using a built-in RF source, feeding into a filter, FFT, and then display. Now, note here, in between the filter and the FFT blocks, there's something called a throttle block. And now this is used because we are using an internal signal source and we want to limit CPU resources. So if you're using a hardware signal source, such as an RTL dongle or hack RF, you won't need that throttle. Anyway, that's just thought I'd throw that out there for now, but as time goes by, you will see more and more about why you need it. So the key components are sources and sinks. So the sources would be your hardware as hack RF and RTL, SDR dongles. Also the internal signal source, which is actually shown at the very top. You can see where up here that's the internal signal source. Now the sinks you can get them you can look at the signal in the time domain or the frequency domain. You can output the data into a file to be looked at on another program or whatever you need to do, or you can just send it to an audio sync, as you can see right here, and you would be able to listen to it on your speaker. Key components, processing blocks is filters, FFTs, modulators, demodulators, math operators, control elements, which is variables, slides, GUI widgets, that kind of thing. You can see a sample of the different things over here Here's your waterfall sync, so you'd be able to observe the signal on your screen. You got an AM demodulating block, narrowband FM transmit. Here, the GUI checkbox is you'd see a checkbox on your display, or you could have a push button, sliders, that kind of thing. Now here's a quick overview of the GNU Radio interface. At the top, we have our, like most programs, your toolbar, and this arrow is pointing at the run button. And down at your bottom, you have your properties panel, so you can see data such as your sample rates, the frequency you might be tuned to, that kind of thing. Basically, what the variables are all reporting or doing. And then in the center of the screen is what's called your flow graph area. This whole thing in here, and then over here on your right is the block library, and you have all kinds of blocks that you can use in whatever you can think of. Best thing to do there is just explore it. And that's it for that one. So one of the things that's neat about or good about GNU Radio is the color coding for data types. So as you're putting your different blocks together, if your data types don't line up, then it's not going to work. So you can see on the right side, I've listed, the blue represents complex, the orange is float, integer for the green, etc. And over on the left shows if you connect your two blocks together and the data mismatch, you'll get a red arrow. You won't get the X, but you'll get the red arrow. If you got the data correct, they're matching, then your arrow and head will turn black. So you'll know you've got the correct settings. Adding your blocks, the best way to do that is just you go over to that's over here. You go over there, grab your blocks, and then you double click on the block of interest, or you can drag it from that block list and just drag it over into your flow graph, and then arrange it in a logical manner, usually left to right, and then you start creating the connections. Now to make the connections, you just click on the out of one and then the input of the next one, and then you'll get the arrow will connect up, as you can see there. And again, as I mentioned in the previous slide, if you have a data mismatch, then you'll get the arrow will be red in color, and you won't be able to go any further. Okay, parameters and versus variables. Now, the parameters, they're set when the block is added to the flow graph, and they can be modified during runtime if the parameter is designated as a variable. And I'll have some examples a little bit later. And your variables are named values that can be referenced by multiple blocks within the flow graph, and they are a convenient way to manage values that are used in various places throughout the flow graph, allowing for easy modification of a single source to update multiple blocks and parameters. And that's no different than what you do when you're programming languages. An example there would be sample rate, because you use sample rates throughout your flow graph. So you would set it up a variable for that, and then you only have to make one change instead of several. And we'll have an example of that shortly. Okay, and here's some examples of settings for signal source and bandpass filters. Don't get hung up on really what everything's doing there. I'm just showing what's inside the block and how you would set up different settings. And then here you would have, this is where you would fix up this the data type that you see on this output. Here's sample rate, the type of waveform, sine, cosine, and of course your frequencies, amplitude, etc. Okay, maybe it's the next slide for the variable. But just to quickly, the variable rate, you'd probably have a variable called sample rate, and you would put in at 32K, and then any block that has the sample rate in it, and here you've identified that the sample rate will be the samp_rate, and they would read that variable and put it in there for you. And again, if you have a bandpass filter, it's using the sample rate, and it'll refer back to that variable and record it there. And this is just a bandpass filter and the settings that you can have for that. Okay, so building your simple graph. This is a can't get much simpler. Signal source, sine wave, 1 kilohertz, amplitude 5, the throttle block that we talked about before, and then the GUI frequency sync, so that when you run it, you can see that signal. And at the top, you have what's called, every flow graph will start with an options block, and that it doesn't really do anything. You can ignore it, or you can put in, like I've done here, the title and the author, that kind of thing. Here's the variable block that I was talking about that will be used by various blocks in your flow graph. And these are your GUI setups, and so there'll be a label marked frequency, and there'll be another selection for RF gain. And then these are just the settings. So for the case of frequency, you start at 0 and you go up to 10K and 500 hertz steps. So again, here's some of the blocks that I've been using in the previous one, and just showing the different settings for each block and how you set it up. So here you got your variable 32K. And if you notice in all this block here, you've got 32K, and that's because it's picking it up from here, the sample rate referring back to here. And again, down here, I'm using the frequency, so that in order to do that, you would control your frequency with this GUI range. You'd set the frequency through the slider. I think that's what I got set up as a slider. And then it would refer back to here, whatever frequency that you selected, and it would generate that signal here. And again, the same thing with RF gain. If you know here, we're back over here where the ID is RF gain, and then as you change the slider for this picks it up and change the gain. And there's the settings within these blocks here, and you can see here I've selected counter plus slider, and again counter plus slider. There's other ones in there. There's knobs and that kind of thing. So, oh, here it is here. So this will show up like this, and you can see here where I have the sliders for RF gain and frequency, and you can see the readout over here. So starting with the basics, begin with simple flow graphs to get familiar with the interface, like I was just showing there. Just put a few of them in there to get something working, and then just play around with all the settings and get familiar with the interface, and bringing in the blocks and setting up the data types and all that sort of thing. That's where I would start. Lots of tutorials available. GNU Radio site has lots of information there. YouTube as well. ChatGPT is a friend. I will say be careful with AI. It can get you started pretty good, and then sometimes you start getting into the really nitty gritty details of something that's not working out right. You might get led down the garden path a little bit, and part of it's probably because of the way I've queried it or asked questions. And anyway, so it's great to get you going on some things, but be aware that it can be a bit of a problem as well too. Explore online forums is another place for it. As you get comfortable with these blocks and bring them in there, make sure you understand each block's purpose. Blocks, of course, can be signal sources, sinks, processing blocks such as filters, mixers, amplifiers. You can, now searching for the blocks, you can use a search functionality to find them, and that can be a help when you're unsure about which block to use, as all the related blocks will become visible to you when you do the search. I mentioned this previously, but understand the sampling rates. Pay attention to the sampling rates, because of the mismatching will cause errors and undesirable results. So ensure that your rates align correctly across all the blocks. Take advantage of the various GUI syncs. There's a scope sync, where that's your friend for visualizing waveforms in real time. And it's often helpful for debugging, as you can insert this sync at various places, various stages in your flow graph. So if things aren't going right at the end, we'll throw another sync, in various places throughout your flow graph, just to see where the signal is going wrong. Frequency sinks, there are more detailed analysis for your signals. You can use that. The GUI can display frequency domain data for perfect visualizing of the spectrum of a signal, or checking for unexpected frequency components as well. When you're running flow graphs on your computer, throttle blocks are crucial, as if you're not using a hardware signal source, it hasn't happened to me, but I'm told that it can hog your resources on your computer. Okay, here's a sample when you want to use the HackRF. I just thought I'd show there's a special block for the HackRF called the Osmocom source. And you can configure this block for various things, frequencies, various gains. If you look down here, you've got RF gain, IF gain, and I'm not sure what BB gain is. And you got various other blocks coming in here, processing blocks. So configuring your processing block, that's like your low pass filter, rational resamplers, wideband FM, multiply blocks. This would be like, for example, you want to get a little bit more volume out of your system. Sinks can come in audio or frequency. And then, of course, with your GUIs, you got sliders, knobs, that kind of thing. So running the flow graph. Okay, so this flow graph will give you real-time updates via the GUI and gives you interactive controls. In this case, we have a knob for volume and a slider for frequency control. So here's what it sounds like. And if I want to change the volume, that would be it there. And this is your tuning knob here. And this is just a local station that I did a recording of it. It came in pretty clear. And this is the flow graph of that FM receiver that we just heard. So it's not too difficult when you go through it. So the Osmocom source and a frequency sync rate on the output of that one. Anyway, the signal goes into your low pass filter, the resampler, wideband FM receive block, a multiply constant, like I said, for audio gain, and then the audio sync. And then this is the tuning label, which was a slider. And then the audio gain, I configured it as a as a knob in this particular case. Now, another neat thing of this, and I know there's a few of us in this group that are Python gurus, I guess. And Python, which of course you know is a high-level language, which makes it easier to integrate and interact with different components of the GNU radio system. And it allows you to quickly prototype, modify, and experiment with signal processing. And you can make your own blocks in GNU Radio by using the Python coding. And then Python has a rich set of libraries like NumPy, SciPy, MATLAB, Plotlib, I guess it is, that make it easier to perform complex mathematical operations, signal processing, et cetera, and use that alongside the GNU Radio blocks. None of which I know about, but I think there might be a couple of us in there that do, or at least could dabble away with the making your own blocks. And on occasion, when you are doing the certain blocks, you'll be in there and you'll be having a little bit of problem. And this is where I started to get into it with ChatGPT and started to go down a little bit of a rabbit hole. And that was starting to modify the Python language scripts that were within an existing block. Not to say that they were wrong, but you can start getting into that. Okay, so tips. If you're working with an SDR hardware, example, HackRF, RTL dongle, make sure your hardware is properly configured and experiment with small scale flows before you're scaling up, like I was showing on an earlier slide. Explore those GNU radio blocks. Try out the different blocks and libraries. Experiment with specialized blocks for signal processing, like the filters, modulators, demodulators. Don't be afraid to experiment with the flow graphs and break things along the way. You know, start with the small changes and see how they affect the outcome and learn from the experience. At least with this one, you don't have to melt solder and use solder braid. You can just change the block, change the flow. And then once you get the hang of it, I think you'll find GNU Radio is pretty incredibly powerful tool for experimentation, signal processing, communications. The other thing too is for those that maybe don't have a spectrum analyzer, you might be able to. You can probably devise one in here. Although you'd have to think about if you want an RF, you'll have to find something that will go down that low, of course. But nonetheless, it's out there ready to do. For resources, go to the wiki at GNU Radio. Lots of tutorials at the GNU Radio Academy, YouTube examples, and use an RTL SDR. And I think most of us probably have an RTL SDR. And for a wider bandwidth, Hack RF. Now I hear there's a new Hack RF or a relatively new Hack RF that's out there. It's far more. I think it has a much larger bandwidth, but I think it's also quite pricey as well. So I suppose I don't have one of those. I've got just a cheap one that I got off of AliExpress, I think. So if you're just going to hack around, so to speak, then I would probably go that route. Unless you put it on your Christmas list, then go get the new Hack RF that's out there. Okay, that's all I have. Am I still sharing here? Or? There we go.
Yeah, you just stopped.
It stopped now? Okay, good.
So I have a question since my mic's already open. Oh, I'll let Howard go. He did it properly.
Okay, Howard, how you doing?
Well, that's okay, Eric.
I'm not really hearing you, Howard. You started off okay, but then you faded right out.
Can you hear me now?
Yeah.
Oh, I was just saying that Eric can go ahead. I just happened to push the button at the same time he was talking.
Well, okay, simple question, actually. Just what are the recommended specs for running it? Like, does it need, like you mentioned, choke points with CPU processing and that? Do you have any idea of, like how much hardware it needs to work well?
All I'm aware of is that if you don't use an external hardware device, you'll need to use a throttle block if you're using an internal signal source. In other words, an internal signal source block directly from the GNU radio. If you're using an external signal source like a Hack RF or an RTL dongle, then you won't need the throttle.
Okay. Fair. Thanks.
Hey. You're up next, Howard.
Now that's kind of my similar question. I was wondering the same. How much CPU power does it need? Like, could you have a standalone thing that runs off a Pi, or does it need a computer CPU?
I'm not sure I'm following, but if you're talking about the hardware, I would say, I stumbled across this. I didn't stumble across it because I was having problems. It was something I had read, and how much computer resources? I got the impression that it'll grab anything it can get, which would cause other things to start slowing down, right? I think that's all it is. So whatever piece of hardware you're using, I don't know why the hardware prevents it, but or maybe the other way to look at it is if you're using its internal signal source, then it'll grab whatever it can get. There's nothing to control it. Whereas I guess when you use an external hardware, it becomes a non-issue, right?
It was an interesting presentation. I didn't really know what this was, but I was just thinking if you wanted to build a little standalone unit that doesn't need the computer, that just uses a Raspberry Pi.
As long as you can run GNU Radio on your on your platform, then you should have no problem doing that. And it's a Windows-based program, or you can run it on Windows. I have not tried it on Linux, but I think you can. Some of the guys I think have. I've also heard that you can compile a GNU Radio file, but I don't know anything about that. So that might be an interesting thing to look at as well.
Yeah, interesting. Thanks for the presentation.
Okay. Kevin.
Yeah, no, I just, thanks, Peter. I haven't played with it for a long time, but I think more processing power is better in my experience. I know back when I was playing something similar to what you had there with the FM radio.
Yeah.
And again, if you don't have the sample rate set right, you get all these overruns. You get a bunch of O's and U's, and you know right away that things are going south.
That's
and,
right.
and the more GUI stuff you have going on that it has to calculate and all that, then that also slows it down. But to the point about using it on a Pi for the backplane radio, when I was alluding to last week, we were talking about, instead of a tone control, like put in a Pi. This is what I had in mind, was like put a thing of GNU radio on there, but just use, just have it set up for audio frequencies. So it's a lot less taxing, right? And a much lower sample rate. And then we could have, with a couple of inputs, you could have a full-blown sort of DSP kind of signal processing chain inside our radio with very little effort. Now, whether a Pi 0 can do that, I don't know. I want to try it out, though.
Yeah. One problem at a time, right?
And because it does run under Linux. I mean, that's where I've generally always run it. I don't think I've ever run it under Windows.
Oh, okay.
So anyway.
Good. Phil, good evening.
Oh, hello, Peter. GNU Radio Companion, which is the IDE, Internet development environment where you generally run it, will run on Linux and Windows and just about everything. It'll probably run on a Raspberry Pi. But GNU Radio Companion, the IDE, when it generates the code that it needs to run, it also generates a version of Python. It'll show a file called .py. So any computer that you've got Python running on, you can run whatever you've built in the GNU Radio Companion.
Oh, I didn't know that. So, okay, so when you run your GNU Radio program, it also generates a Python file, and you can take that Python file and then run that in the Python environment, right?
Yeah, you look in the same directory as you're running all this, you'll see a .grc file, which is a GNU Radio Companion, and you'll see a .py file. So you can use either of those. If you just have Python, you can use the Python file.
Oh, I wonder if that's what I was talking or what I was reading about then, and just misinterpreted as a compiled executable file. But okay, have you tried that, Phil?
Oh yeah, I have.
And so there's no difference. You saw no difference between the running it under Python versus the GRC?
Well, sometimes you run up against issues of you have to install additional libraries or blocks effectively in Python, but I don't think in general it's too difficult.
Okay. Well, that's interesting. That might simplify things. Kevin.
Okay. No, just to follow up to what you're saying, Phil, it's like, I know it generates a Python file, but if you have some application that's doing like, I don't know, 20 million samples a second, you still can't run it on a Pi, right? I mean, you need the calculation capability of whatever you're going to run it on has to fall within, whatever it can handle from that flow graph, I think, right?
Oh, absolutely, sure, yeah.
Yeah. Okay. I thought that's what it was. Have you tried running it on a Pi 0?
I forget. I may have. In fact, I think I have, but it's quite some time ago now. I don't remember.
Okay. I know I've run it on a Pi 4, but I've not tried it on a Pi 0. So
yeah, I think when I ran it, it was on a Pi 4.
Okay. Yeah, that's what I had luck with anyway. Okay.
Just one other little point that maybe Peter did mention it, but he was showing things like the HackRF as a source, which means it's a receiver. You're receiving via the HackRF. But since the HackRF can transmit, there's a HackRF sync. So you run your audio or whatever into the HackRF, it'll transmit that. So you both have sources and sinks for a HackRF. You can either receive or transmit.
And I did dabble on that a little quite some time ago, where I set up for 2 meters, and I had the HackRF transmitting on the 2 meter band.
Yeah, well, I set up a thing recently here where guess I showed it at our breakfast, where I was using GNU Radio to transmit GMSK data and receiving it on a laptop using my RTL SDR dongle. But there's really no reason on a computer that's reasonably fast that you couldn't have the HackRF plugged into one USB port and the RTL SDR plugged into the other port, and you could be transmitting from one port via your HackRF and receiving on the other port with your SDR. And I shouldn't have any problem doing that.
Limits to your imagination, I guess, Phil. Eh?
Oh, it's an amazing, and you mentioned AI. I find the best AI to use with GNU Radio and lots of other things is Claude.ai.
Mm-hmm.
And although it will make some mistakes, as long as you explain to it what it's doing wrong, Claude is very, very good at getting it right and writing a customized block. As you mentioned, there are customized blocks available, which is just basically Python code. And it can do amazingly good work in building these customized blocks.
Yeah, that's good to know, especially when you're starting to dabble into some of these other little things there where, you want to modify the signal some way, whether, as Kevin mentioned earlier, maybe tone or who knows, or DSP stuff you want to start dabbling with. But that's out of my realm of experience, that's for sure.
When you look at all the blocks that are available, there's I don't know, hundreds of them there.
Oh, yeah.
It's amazing. And then you can ask an AI thing like Claude to explain what those blocks do. And he does a pretty good job of explaining those blocks too.
Yeah. I've done that a few times too. Went to AI and said, what's this block for? What's that for? Not so much how do you use it, but what is it?
Yeah.
But I think I was starting to run a little bit of trouble when ChatGPT was having me modifying the Python code in one of the blocks. It was a while now, so I can't remember exactly the details and how I got out of that rabbit hole, but eventually I did. Any other questions? Comments? Dave?
Yeah, can you hear me okay?
A ton of noise.
Right. What's up?
You got a lot of noise in the background going on.
Okay, because I'm actually doing this from my virtual machine. I was just testing it to see how it's working.
Not well.
So, or is it inaudible?
A lot of background noise, Dave.
There, I've enabled noise suppression. Is that enabled noise suppression? Is that better?
Good. I didn't quite say it again, Dave.
Okay, never mind. There.
Okay. Yeah, unless somebody else caught what Dave was saying. No. Go back to whatever you were using before, Dave. Oh, he's gone. Scared him off.
I mean, we're hams. We can decode what he was saying, right? But that was not very high fidelity.
No, he started to get a couple of words in there, and then all of a sudden it just dropped right out. So whether he's going to come back in on a new one or not, I don't know. Okay.
I think he's on the virtual machine, bandwagon for everything, right? He's even got Joanne virtualized now. So.
Well, actually, I did some online testing with Dave there a couple of weeks back, or maybe a little bit longer than that, with communicating. And I thought he had it all straightened out, so I was surprised that he was that noisy.
Yeah, well, I'm sure your mileage varies when you're starting to run audio interfaces through various levels of reality or whatever.
Yeah. Okay. Does anybody else have anything they would like to discuss? Any questions or queries?
With regards to your presentation, or?
Well, that or something else that's maybe on your mind.
Okay, I have another question with regards to your presentation somewhat. You mentioned the HackRF interface, but what about other products, like RTL SDR?
There's Lime SDR, which I'm sure Kevin would like to sell his to you.
But I mean, do they have sort of functionality similar to the HackRF? Seems to be somewhat integrated.
I'm not sure what the comparisons are to some of these other ones. The only other one I'm aware of off the top of my head is Lime SDR that Kevin, I think, got an original one way back when. And I'm sure there's other stuff out there, the names of which escape me. And I imagine they all do more or less the same thing.
Right.
Try again, Dave.
Yep.
Or does that answer your question, Eric?
Yep. Thanks.
Yeah, this should be working better now, right?
Yeah, way better.
Yeah, no, because I'm on my host now. I was just testing VM. I was actually going to test on the laptop across there, hooked up to across the VM and sharing my camera. But anyway, it doesn't matter. Yeah, I just wanted to ask you. It seemed to me that I ran across something about GNU Radio you were able to take that flow chart, that flow you did. You could take that, export it, and create an application out of that, automate. It seemed to me, I remember you had the capabilities to do something like that, but I can't remember. Did you run across anything like that?
Well, I did. I'm surprised how you missed it. But anyway, I was aware that I've been told that you can compile the GNU Radio file. But Phil was just telling us a few moments ago that when you generate the run or on your GRC file, it also creates a .py file, and you can take that file.
I thought he was talking about a plugin. I thought he was writing like plugins, talking about plugins in GNU Radio, that where you could create a module and you could have a custom. That's what I thought he was referring to.
No, well, both. We talked about both scenarios, where you can create your own module with Python, or block. But Phil was telling us that when you run the GNU Radio flow graph, it generates a py file that you can now run in the Python environment. So that's an interesting thing that I wasn't aware of before. So that might be an interesting thing to try as well.
Yeah, I saw that. I saw that somewhere where you could compile it and you could generate. You could take it and you could run this repeatedly as opposed to running it within GNU Radio. So that's how it's done then. It's done via an external Python program.
Yeah, so it'll be interesting. It'll be interesting to try that. I'll query Phil more about that on Saturday. Frank, you got your hand up.
Yes, the question Eric had about source for GNU, and what came to mind was one of our projects that we had a few years ago. And I was wondering if that would work as well. I don't know if you've tried it or not. Do you recall the project?
We used the RTL dongle, right? And we used the little pup, our up converter.
Yeah, the little pup.
Yeah, you can use the RTL dongle. I've used both the RTL dongle and the HackRF for basically the same thing. Of course, the RTL dongles for receive only, and whereas the HackRF you can use transmit as well. But I've used both the RTL dongle and the HackRF. Others I haven't tried at all.
Yeah. The little pup was receive only, so
Well, it's designed to be used with the RTL dongle, so we didn't
very similar. Yeah,
we didn't have to worry about transmit. And I suppose that's a good way of getting around. Just for those who may not be familiar, that project Little Pup was the one that down converted from the higher bands down into the HF band area.
Yeah. The other way around. It was up converts.
Oh, sorry. Yes, you're right. Yeah. After I said that, I thought that didn't sound right. You're right. You could take we were aiming at taking the HF stuff and boost it up into the frequency that the RTL dongle can receive. Yes, you're right.
That's where the name come from, is the UP in pup.
Yeah, up. I knew that. I was just testing to see if you guys were awake.
Oh, okay. Anyway, very good presentation. I enjoyed it.
Okay, thanks. I'm just trying to think else. And Kevin, Kevin, you had the Lime SDR there. I think that's what it was called, wasn't it?
Yeah, It was part of a Kickstarter crowdsource thing, and there was issues with the circuit board and some other. I still got it sitting in a box here, but I could never really get it working well. So I kind of just put it aside and said I'm not going to waste any more time on it. And the support, they were still writing drivers and all this kind of stuff. So I kind of left a bad taste in my mouth for a lot of this Kickstarter kind of stuff, especially if there's heavy development needed. So anyway, but I mean, like Edis Research has one. There's another one, the RF Blade or whatever. I think the one that Hassan has. They're a lot more high end than the Hack RF. Like I was just looking at the Edis Research ones. I mean, they have some that have like 400 megahertz bandwidth, right? I mean, and I think the Hack RF is up to 20, and the original Hack RF is only 2. So anyway, so yeah, depending what you want to do with it, that, and then of course, the money goes up accordingly, right?
Yeah. I see that Lime SDR crop up every once in a while. So it looks like
I think the newer ones, like the chip is actually, it's a pretty great looking chip, a lot of promise, but the way they implement it on the board, or I don't know what all the issues were, drivers, whatever. Maybe I should pull it out and power it up again. But it was kind of tough, like when I did try it anyway. But yeah, I've seen it around too, but I'm certainly not spending any more money on one.
Well, power it up, say it works, and then Eric will probably buy it from you. Problem solved. Phil.
Yeah, just a comment Kevin said about the ETIS transmit receive module, like a really super Hack RF. The very, very common one is called a USRP B for Bravo 210 SDR. And it's the one that most universities and other organizations use as the command and control station for amateur radio satellites. And RMC is putting together a satellite at the moment, and we have already bought one of those B210 SDRs, and it's a dual channel. They had as Kevin mentioned, a wide bandwidth, a wide number of frequencies it can operate on, at least up to 6 gigahertz and maybe beyond. And as I say, every university pretty well is using that as their main ground station command and control radio. So it's very powerful, but it's not cheap. It's around, I think it's around $3,000, something like that.
I still haven't recovered from buying my spectrum analyzer, let alone go buy one of those things. But wow. Okay. Any other comments? Well, who's got a Hack RF anyway? Is it or RTL dongle out of this group?
Well, I've got a Hack RF and a variety of RTL dongles.
Oh,
Yeah.
Yeah.
I have both.
There you go. You make up for these guys that still don't have their cameras on, can't see.
Just
Well, I'm doing you a favor.
I'm just looking at that B210 Edis Research one. They call it their low-cost SDR. So that they say experimentation with low-cost SDR, and that's the B210. So you can imagine what the really good ones are.
Wow.
And it's 56 megahertz of bandwidth.
Jeez.
Wow.
So yeah.
So you can pretty much play wherever you want to play.
All at the same time.
Yes, very true. Okay. All right. Well, we still have a little bit of time left. I know we ran out of time last meeting there. So what I thought maybe we could carry on with a little bit was since this is the last of the meeting, and maybe you guys might maybe just do a quick roundtable and talk about what you might like to see in 2026 for presentations, subject matter, what interests you, whether it be tutorials on something, projects, whatever. I'm sure it must be something on your minds. I know we've had a couple of presentations that were off topic of what we normally do with homebrew, so maybe you might want to comment on that, about presentations that are not quite strictly electronic homebrew stuff, but still may have some interest there too. So maybe you might want to make a comment on that one. So with that, first on my list for a comment on that would be you, Kevin.
Okay, well, that doesn't give me much time to think about it,
Well,
but
I could ramble on a little bit longer.
no, it's just I don't. I mean, I kind of like this hack RF stuff, like and GNU Radio, because I've always wanted to do more with it. And actually, I have some stuff coming down the. If I can ever get through this KiCad thing with this power supply board, and I'll up that learning curve, then my next project is like a Raspberry Pi and a hack RF and a antenna and some other kind of stuff that I want to do. But yeah, so I kind of like that stuff personally, because that's more high techy stuff. And I'd like to know more about, like, as I've mentioned in the one email, about gigahertz stuff, like microwave stuff.
Mm-hmm.
But I don't know anything about it, and
I think there's going to be a steep learning curve on the gigahertz stuff, that's for sure. But
we're here to learn. That's what's a day without a learning curve to climb, right?
You think you're having trouble with KiCad now? Just wait till you design a board to operate on gigahertz.
Yeah.
Okay. All right. Thanks, Kevin. How about you, Charlie?
I've spent the last little while trying to get a collection of the kind of standard ham radio software working under Linux. The vast majority of the stuff is Windows only. And so getting things operating either under Wine or other methodologies for trying to get that stuff running. And I've been surprised. I'm having a fair amount of success. Those tools have come a long way in the last couple of years. So I've, for instance, WinLink is probably the one that most people have a hassle with. WinLink and the Vera codec modulator. Vera I've got running quite happily, and I've got WinLink running as well. I'm just trying to figure out how to assign a serial port like a COM1 to a Linux device, and I think there's an equivalent of a registry to go and dig in, which is makes me a little bit nervous. But anyway, that's kind of what I've been wrestling with for the last little while. Not that I'm keen to use those tools. There's a version of WinLink, for instance, called PAT, which is quite powerful, runs natively under Linux. But number of other folks that I hang out with are pretty dedicated to the Windows versions of that software, and so seeing if I can get some of that running to let them move away from the Microsoft machine is kind of one of my objectives. Outside of that, lots of really interesting topics here. Stuff that's not necessarily radio electronics related, I find fascinating as well. Dave's rockets were a really cool presentation. That kind of stuff. I think I find most of the people here, like myself, have a wide range of interests, and so hearing a few things that are outside the normal electronic scope is great stuff. Gets the old brain cells going. And that's it for me.
Okay, good. Thanks, Charlie. You mentioned about the Linux, and I know off the top of my head, I know you and Dave have really gone down that rabbit hole of late. I suspect that Dave has actually gone out and got a tattoo of Linux for him, but maybe somewhere along the way this year, maybe. And I know there's more people out there looking at converting over to Linux, so maybe there might be a presentation that someone can do that talks about how to get away from Windows and go into Linux.
We'll get some Penguin T-shirts before we do that. Dave and I have gone sort of different paths. Dave is having all of his machines on one piece of hardware, using virtualization. I've gone the other way. I've still got a number of machines rolling around, but I'm taking snapshots of those machines with CloneZilla. So if I take one of my Windows machines, I'll convert it to Linux by making basically a backup of the Windows machine, and then if I get into trouble or I need something that I've forgotten, I can put the Windows machine back on the hardware and run it again to find the things that I'm doing, and then go back to Windows. I've done that once so far. I've had some files that I've been missing, but over the past I'm going to say 3-4 weeks now, I guess, it's been Linux all the way.
Okay, good. Okay, thanks, Charlie. Frank, good evening. What topics interest you and whatnot? What would you like to see for 2026?
Well, what I've been working on is this software controlled dial type thing. It's become quite a project, and I've learned a lot, but it's still not working. So I more or less cleared my bench until after the holiday season. But where I was interesting, and so much as I was looking for tutorials on how to connect the ESP32 with the FTF display and run it under a Arduino IDE. And the one sample or one tutorial that I saw used the same display that I'm using, only it also used the touch feature. Now, in my project, I don't use the touch feature at all. Excuse me. So I ventured into that as a side deal and tried to get it working because it uses exactly the same hardware that I'm using. And that's when I put it all together and programmed it and everything. And all of it worked except the display. And the idea of the program was to touch someplace on the display, and this display was supposed to tell you exactly where you touched and where it is and how much pressure you put on it and all sorts of stuff. Well, I got that in the IDE when you can switch over and look at the output from the processor from the ESP32, and everything was fine. I touched it and it would display down in that box, but nothing came up on the actual display itself. I was just touching randomly at places to a blank display. So you're talking about possible presentations. I would like to see a presentation of someone who is working with this combination and let me know where I'm going wrong. What I figured at first, it was the ESP32 module. So I bought a new one of those and exactly the same. Then I thought, oh, well, it's got to be the display. Well, I bought a new one of those and exactly the same.
Frank, you mentioned the ESP32 hooked up to do what, an FFT display, did you say?
Yes,
Okay.
the FTF.
What's FTF?
TFT.
Oh, TFT. Okay, got
TFT then. Oh, sorry.
Okay.
Sorry.
Okay.
I put it away for a while. In fact, I forced myself to forget all about it until over the holidays.
Okay. Yeah.
Anyway, that would be an interesting presentation.
Okay.
And one thing I did learn through this tutorial was that there were two types of connections that you can make between the display and the ESP32. One is VSPI, which I think stands for virtual interface, and the other one is HSPI for high speed. When you change programs, you have to be aware of which one you're connecting to the display. And that got me into a rabbit hole for a little while, but I finally got out of that one. Mind you, if I ever get this thing working, I'd like to do a presentation on what all these last few months have been about.
Well, you'll have to combine it down to about 20 minutes or 30 minutes to the presentation, Frank. Don't spend.
Yeah. Okay.
Just a quickie on it wasn't a TFT screen I was messing with, but it was interesting in so much as I was doing this project and anyway, long story short, I could not get the screen to work properly. It was erratic. And it was one of the few times where ChatGPT actually really helped out when I was having big problems. And it said to me, by the way, have you got the pin 38, I'll just say or pin 15 grounded? No, because the instructions didn't say anything about grounding pin 15. So looked on the data sheet, sure enough, it showed a different pin, but I grounded it and there we go. Worked fine. So you never know.
Huh?
So check your grounds.
When I get back to it, I'll do exactly that.
Okay, Dave, you have a comment? You're muted.
Welcome to my nightmare. now you know exactly what I went through when I wrote the software for the SNA, because that had the same TFT display, and it was a nightmare getting that thing to work. And the problem was the library. You just got to make sure you're using the right library, because it seems that all these TFT displays use a common library. They don't. So you just got to find for that TFT display what library is compatible with it, because I'm sure you're using a library. And that HSPI, VSPI, I don't want to get into that right now, but it's just SPI. It's just SPI interface, and it's how you interface to it, right? But check your, chances are it's your library that you're using.
Okay, Dave, thank you very much. That did occur to me, but by that time I had lost patience with it. But I haven't given up. So we'll see next year what next year brings.
Okay, perfect. Great.
Okay.
Howard, you're up next. You got a whole raft of things going on. What's going to interest you in 2026 for a presentation that maybe you'll do?
Well, I don't know about that, but in terms of, everything's so new to me that everything we discuss is interesting. So I don't have any particular area, but just kind of, it would be interesting sometimes to allot some time to troubleshooting, just kind of sort of like the back and forth that went back here with Frank and Dave. If someone is working on something and they're having trouble with it, then can email somebody, whoever is the coordinator for the meeting, and saying, to allot some time to discuss the problem where everybody that has more expertise than the person with the problem.
I think that'd be perfect. That'd be great. Yeah, if you're having issues and whatnot, this is the right forum to talk about those issues.
That's my only suggestion.
Okay, that's great. Thank you. And I'll be looking forward to a T41 presentation this coming year too, right?
Right. I'm getting there.
Okay, thanks, Howard. Hey, now things all changed up there. Phil, good evening.
Okay, Peter and Drew, you both know that here in Kingston, we've suddenly fallen into this rabbit hole of Meshtastic. After talking about it for so long, we're finally getting a bunch of people with the hardware and the software, and we've been trying things out. But I'd like to know what people do with it besides sending a short message saying, "Do you receive me?" and getting a reply back, "I receive you." And maybe hooking up a temperature humidity sensor and sending that. There must be more interesting things that Meshtastic does, and probably a whole bunch of them, but we really don't know about it yet.
No, and the guy who probably does know a lot about that is Joe, V3POR, but I haven't seen him out for a meeting for a while now. But I know he was really getting into hooking up some Meshtastic stuff, but I don't know. I mean, he was hooking up a bunch of sensors between a couple of apartment buildings and stuff like that, I think. But anyway, I haven't seen him for a while, but the next time we see him, we'll have to ask him. But great. Okay, thanks, Phil. Yeah, I know the Meshtastic thing is really starting to take off over in this neck of the woods for sure. Al, good evening.
Good evening. Well, I'm not sure what to say. It interests me. A couple of things. Kevin spiked my interest there in microwaves. I'm wondering whether either amongst ourselves or whether we could bring somebody in. I'd love to hear a presentation on microwaves, how to get into it, and what do you do once you're into it, and sort of microwaves 101. Kind of interests me. The other that's in the back of my mind, I know it's kind of retro, but I do like vacuum tubes. And I'd like to, years ago I built a novice special from the 1970 ARL handbook, a 2-tube unit. And it took me 40 years to finally build it, but one of the drawbacks I find with a lot of those old circuits is they're crystal bound, and they're also using old original crystals, which are fairly current and heat insensitive. So if you try to build one of these things, like a Tunitin special, they suffer from chirpiness and droop in the signal. Because often when you buy a crystal, the senders are taking an old, like an FT43 case, and soldering in a new modern small crystal. You put it into a vacuum tube circuit, and it overheats, and let's just say the transmitter has quite a lot of character. And that's being polite. So it's always been on my bucket list to come up with a hybrid, like a digital VFO for as a crystal replacement for a vacuum tube QRP transmitter. So that's the type of thing that's going on in my mind. Of course, I'm all ears with Frank's VFO project. I think that'd be a great buildathon and a nice module for additional projects that we might want to build. So that's kind of where I'm thinking. A little bit of vacuum tube, maybe. Maybe other people share my enthusiasm for it. Maybe not. I know it's 50 years obsolete, but hey, what the heck? I kind of like it. What do you got there?
Some vacuum tube. I got a bunch of them, a couple of them here, and I thought I'd build a circuit that would light up the heaters and just have them glow in the dark kind of thing, but I never got around to doing that. But they collect dust.
Well, hey, there's a do-it-yourself vacuum tube kit from A1 Electronics, Glenn. He bought a warehouse full of old, fairly large vacuum tubes. Most of them are just DC rectifiers. Was it an 804 or something like that? And what he's doing is he's knocking off the glass teat at the bottom. That's the one.
Yeah.
And inserting a cobalt blue LED and a power supply, mounting it on a case or a wooden base, and now you've got a nightlight that just glows. It's actually kind of cool.
Oh, that'd be neat. Yeah, this is a VU71.
That's kind of what Rex did with his thing, right? You know, a glowing orange LED in a vacuum tube or something like that in one of his kits. So.
Well, you know, way back when, Frank will remember, this is going back to when Gord was part of the group. And I think Gord was actually the player behind it, the main one. We had decided we were going to do a vacuum tube project. and I can't remember whether it was a receiver or a transmitter or an amplifier. I can't remember what it was. I do kind of recall there were some problems with it, but I just don't recall what they were because that was a long, long time ago, and I guess it just died a death of whatever. But Frank, do you recall? You're still muted, Frank.
Okay. Yes, I do recall the project very, very clearly. It was going to be a transceiver originally, but the transmitter part was the one that gave us some problems, and the voltage required to run that transmitter. We were trying to get it down to something like 45 volts or 90 at the most, and we just couldn't get the power out of it at 90 volts. Anything above that, we didn't even want to touch because of the danger of builders electrocuting themselves. But I think the highest we went was 90, but the power, the efficiency of an old tube just didn't make it at all. So that's what pretty well killed the project.
Okay. Oh, thanks for that. Okay. What else we got here? Okay, who's up next? Drew.
Boy, that's a tough question. Rather than suggest something, I thoroughly enjoy the range of topics that goes through this group. And there isn't a week presentation goes by that I don't pick up a lot of stuff to go and dive into and learn. So I really have enjoyed that. And yeah, the Meshtastic has been interesting, but it's kind of coming out the way I thought. It has reinvigorated some interest in local mesh networks, which I think is a more interesting topic. And as Joe has discovered, a very useful one if you happen to have information you want transmitted. You don't want to go on the internet like we had today. I don't know, Peter, if you were down for a few hours. I was.
No.
Everything was down, I think, for a few hours. But
we live on the right side of town.
Yeah, I would say so. You must pay more taxes. I'm not sure. We sure got knocked out anyways. I honestly don't have a lot of suggestions. I'm really enjoying the topics as they go along.
Okay, well, that's good to know. And then maybe you'll do some more balloon stuff in 2026 and give us a little balloon presentation, Drew.
Well, yeah, I have built the electronic bits, the physical bits, building the hydrogen and oxygen collector, and taking great pains to make sure they never see each other in the gaseous form. And as I do that, of course, my wife will confine me to the backyard, and I dare say if anything goes wrong, the neighbors will be upset.
I think I'm going to get a camera like Dave has, put it on top of my tower and have it aimed towards your neck of the woods.
Well, the thing is, there's never any color to the explosion. It's just a lot of air moving really fast.
Okay.
Yeah. Anyways, yeah, I agree. It is something I want to do. One thing that has me a little leery, and I understand from the presentation that was given to this group that there are no rules governing this. I'm still remarkably queasy to be releasing a balloon into international airspace with my name on it. Just for fear it comes down in the New York Thruway and, lands on some guy's truck window or something. But other than that, yeah, it is progressing. There's a lot of drama in that group mid-year. I think it's settled down now, and the software for the equipment that I bought, the PCBs and the like, is now available again. For a while, it was pulled off the web.
Oh.
So there was a kind of group drama that does happen from time to time amongst a lot of bright people, and it's settled down. So that part was good. I think Charlie's group is getting kind of interested in doing this, and we'll see where they go with it. I think they're progressing along with a different hardware software package than the one that I'm using. Not sure.
I see the California guys have they launched the balloon a few weeks ago, and they put Doug Hendrix's call sign on it, and it's gone around the world. I think it's gone around the world at least twice, if not more.
Yeah,
So
yeah.
it's still going around.
Some of these things make 12, 15. Some of them have been up there for a long time. KCL has done very well with his.
Yeah.
Anyways, that's absolutely on the. I will provide updates on the balloon thing. Subject to a no detonations.
Very good. Thanks, Drew.
Yeah.
So, Eric.
Yeah. You could give Electro Boom a run for its money. Maybe you could be like a guest speaker on one of his episodes. So
I have a Jacob's ladder.
Yeah, there you go. There you go. I don't know if you'd want to have Sparks though with what you're doing. That might not be a good combo. Anyway, sorry, not a lot of strictly speaking RF things on my plate, but what I am doing is making a laser cut enclosure. So I'm learning a little bit of CAD program called QCAD. Which is favored at the makerspace, the DDO that I'm part of. Anyway, so I've got a Morse code tutor that is just the raw board with control switches and all that, rotary encoders that I want to get a little familiar with laser cutting. So anyway, I've just done simple boxes now, and now it's just a matter of getting used to this software and cutting out all the holes and that, just a different way rather than 3D printing it. So anyway, yeah, sorry.
So what do you have? A laser head mounted on a 3D printer, or
no. The DDO makerspace at DDO has not one, but two full-size commercial laser cutters.
Okay.
So, yep.
Okay.
Yep. So anyway, so it's something I have access to as a member of that group. So that is kind of what I'm working on at the moment. Like I said, not melting solder, but I ought to get back to that soon. If nothing else, finish off my DCR build that I started at the cottage last month. So.
There's always 4 days at Eric's Cottage 2026. Speaking of laser cutting, I haven't read anything for a while, but I was aware that there was some laser heads that you could get for your milling machines, the CNC machines, and stick them on there. But I don't know how powerful they were or how well they worked. But
probably more for engraving than cutting, right?
Oh, I hadn't thought of that, but probably. Drew.
Well, you mentioned something that intrigued me. I bought one for my 3D printer head, and it's pretty anemic. Once I realized that people were getting 30 and 40 watt lasers to do cutting, and I think mine is like 5. But the interesting thing is that there was absolutely not a blink at the border.
There is not a blink where?
At the border.
Oh. Huh.
Well, isn't a 5 watt laser more or less a pointer? No.
Well, no, I think it's about 100 times more powerful.
Oh, okay. Oh, that's true. Yeah, the milliwatts for pointers, right? Yeah.
Oh, yeah. The green ones I think are 20, and they're pretty. Anyways, the average range, the head weight is not heavy on these, Peter. You could easily put it on your head on your 3018.
Yeah, but if it's not going to cut.
Oh, it will. If you get a 30 or 40 watt, it will, but you better make sure it's undercover, because I think that's when things get pretty interesting.
Yeah. Well, we'll figure.
Ones are 100.
I guess we'll figure out 3D printing first before we go down venturing cutting stuff up like Eric does.
Actually, while I'm still here, has anybody got any experience printing with more flexible filaments with 3D printing, specifically stuff called TFU, Tango Foxtrot Uniform?
I used Tango Papa Uniform.
Okay.
And it's, do you have a direct feed head?
No, I understand that's kind of important for these softer filaments.
Yep.
They get bunged up in the tube.
Yeah, the Bowden tube, it'll just block it up.
Right.
If you get a direct feed head, I have a direct feed head on one of them. And even then, I had to put in some little blocks to keep it oriented as it came through the heater block into the nozzle.
Okay.
It does work very well. I made an esophagus with it, and it is pretty cool stuff. TPU is something that I would like to get back into. It's the usefulness of a flexible fiber is underappreciated in what we're doing. We can make a lot of stuff with it.
Did you have any problems installing your esophagus?
Well, oddly enough, it fit with a little glue. It was tricky actually. The way it was intended as a model to teach nursing students how to do a cut down.
Okay.
And it was being sent up north to a reservation.
Right.
And Dr. in Picton wanted to get this model printed during COVID. Nobody really knew. So, fearing nothing, I just went ahead and did it.
Right.
And damned if it didn't work. But yeah, TPU is a bit of a fuss. But you need a direct feed head. Is the first thing I would tell you.
Yeah. Okay. Very good.
But you can replace the Ender 3 head with a direct feed. A lot of people do it as a matter of course.
Right. Because it works fine with all filaments, the direct feed.
Oh, yeah. The Bowden tube is candidly quite annoying. I don't like it.
Right. Okay. Thank you.
Okay. All right. Thank you, Eric and Drew. Dave, what's going through your mind now that you finished up with Linux?
Yeah, so I wrote down a couple of things here. So, just one comment. Hey, Charlie, take a look at Time Shift. Don't bother with that Clonezilla. I've done that. It takes way too long. There's a program called Time Shift, TIMESHIFT, Time Shift, and it takes a snapshot of your Linux install, and you could recover that. It's a lot faster. It is really fast, and if you make a mistake, you could revert back. But anyway, so in terms of other projects coming up, I think there's general interest. If you look at some people in the group around hacking, and I know that Kevin has talked about, doing like a capture the flag RF type thing and doing stuff like that. So, like maybe something around using Hack RF to do replays and stuff like that. I know that way back when Hack RF got banned, or was supposedly going to get banned in the UK. This is when it first came out, because people could record and play back key fobs for cars. And then since then, they've put in rolling security keys and stuff like that, which kind of defeats it. But anyway, that would be something interesting to someone to talk about, is how to use Hack RF to do some of that stuff. Back to basics. We had dabbled in that for a while, and I'm not really, this is what a transistor does. This is what a resistor. I'm talking about back to basics, about some basic things which typically we don't use, or we don't, get involved much with. And it might be good to just dust off some of that stuff, a refresher, so we understand how like AGC, how does an AGC circuit work? How does a blah, blah, blah circuit work? Like just something, to take us and refresh us, so we keep it at the front of our minds. The other thing is that we've done a wealth of like presentations. Over how long have we been doing presentations now, and how many's on YouTube? A lot. So it might be interesting to go back to some of the early ones, dust them off, and do them again, or do a summary of it and point back to it and say it's talked in this presentation, but here's a 2-minute overview of what that presentation is. Because we had talked about maybe doing a wiki for all of our presentations, and identifying what our presentations talk about, and that might be a good use case for us going back and doing that. And from that, we generate that kind of information. Projects, I think, everyone is doing something. It'd be interesting if everyone would take 5 minutes or 10 minutes and not as just as a round table, but just something a little bit more formal, not too formal, but just talk about, a project they've done or they're working on. I think everyone here has done something at some point, and it'd be just interesting to hear about it, because it seems it's always the same people doing presentations. We get to get some fresh meat, some fresh perspective, some fresh things. And that's why it's interesting coming back to what Drew was saying about, we have a diverse set of things that we talk about, and that's great. And it'd be good if we could continue that and we'd get some other fresh ideas, fresh things that are people doing, even like music. You guys are all into music. Maybe there's something about electronics that you guys could talk about in music. I know that Kevin, you and Peter were talking about that site you found where you could just take a schematic and just drag and drop it into KiCad, and you were talking about some kind of fuzzing pedal or fuzzing something or other. So, even something like that, that'd be interesting to hear about, right? So it doesn't have to be all about our, our light wheelhouse.
You want me to start playing White Christmas? I can.
Shut up, mute him. Can we just exit?
Yeah, I'm kicking him out now.
Anyway, that's my 2 cents.
Okay, lots of good stuff there, Dave. Dave's a few notes there. So see, and that reminded me as well too. Another thing we should probably explore a little bit more, maybe this coming year, would be topics of interest. So we don't necessarily need to have a formal presentation from somebody. We could have a topic of interest where we would all participate in whatever the topic is, of course. So everybody, put your thinking caps on, and the topic of interest could range from basically anything. Whether it's about how a certain component works or a circuit works or whatever that you want to talk about. Troubleshooting techniques, that was mentioned earlier. Okay, Kevin, you had a comment?
Oh, okay, hang on. No, just, a couple things. One is, the Lima SDR chip is actually in the Blade RF SDR. So it's available anyway, just because it is a good chip. At least it looks pretty good. The other thing was that RF capture the flag, and it's more of an in-person thing, but if anybody doesn't know what that is, it's something that they did at DEF CON, I think, a couple of years. I'm not sure if they're still doing it, but basically what they do is in their ham radio village, the flag is just a string of text. That's it. So what you do is you take the string of text and you encode it in some kind of RF signal, but you don't necessarily tell anybody what the signal is or what band you're on. So you have to have some smarts to figure out, okay, this is a signal. Oh, maybe it's RIDI. And then you have to decode it, figure it out, get the flag, and then that's a clue for the next signal. And you might have a bunch of these, and it's like a competition. It's like fox hunting on steroids. You not only have to find the transmitter, you have to figure out the band, the mode of transmission, and then also decode it. And I thought, that would be, that would stretch our abilities to, you could make it fairly easy, but you could also make it pretty challenging, I think. So anyway, I thought that sounded like a lot of fun. But
yeah, it does. It does sound like an interesting thing to try out. We'll have to talk about that a little bit more, maybe as a topic of interest, Kevin. And just
I wasn't talking about as a project. I was talking about like a presentation. Someone could, Kevin, if you want to talk about capture the flag, how that works, yeah, by all means, that would be interesting. I wasn't talking about us doing it as a project.
Oh, okay.
Just as a topic for us, someone to talk about. It's like using, how does a replay attack work? How does it work? How do you use HackRF to do a replay for a garage door opener? Because if you go back, because as Peter was talking about the GNU radio stuff, it jogged my memory, and I remember Mike Osmond has done a whole set. He's got about 10 or 12 videos, and he goes through all this stuff in HackRF using GNU radio, and how you could make an FM receiver, and he walks through all the modules. And then at the end, he shows you how he can control a RC car and how he can open a garage door doing a replay attack.
I did a replay attack. One of our talk about our presentations. I did a replay attack on my garage door years ago when I was back in the city with a Portapack, which is a Hack RF based unit. So yeah, that presentation actually has already been done.
That's right. I forgot about you had that Portapack. Yeah, you should do a little chat on that one sometime.
Hence, dust it off.
Yeah,
well, it is. It's actually within reach here on my desk, and it's due to be powered up again and dedicated to some stuff.
See, and Kevin, that's exactly my point there. See how quickly we forget the presentations that's done? Okay, so that's why it'd be good if we go back and we look at some of those presentations and we dust them off and we say, okay, Kevin, did this presentation back and blah, blah, blah. Here's a 2-minute summary of what that presentation was. I encourage you to go back and look at it. So it refreshes us. So, because we've got so much information at our fingertips, and for us to gain access to it or remember it, it's difficult. So this might be a good way, like a back to basics kind of thing, where we refresh some topics.
it's too bad we couldn't get ChatGPT to view our videos and then give us an executive summary. Okay. Well, Michael, you're the last to. You've had tons of time to figure this one out, so we're all bated breath.
Well, I got some of it. Well, yeah. Let's see. Talking about redoing old projects and presentations and things like that. Things like the SNA. I need to relearn how to use the SNA and that kind of thing. When Dave was talking about the things he was talking about, the radio fundamentals stuff, Radio Fundamentals 101, which is a set of videos on basic radio stuff. And Peter and I have been talking about me doing something along those lines in 2026 and things like that. Also, how to use your equipment, like what do the buttons do? So I'm still learning that. Like I run into problems with my oscilloscope today and things like that. What else? I want to learn KiCad better than I know it now. So KiCad and LT Spice. So maybe there's something there. Like I need to learn this kind of stuff and teach myself. And I'm looking at the backplane. I'm thinking, well, maybe eventually I can build some boards, like just basic transistor stuff. Putting a little transistor amplifier in. I've been thinking about this. How do you go about experimenting, learning about the Miller effect and stuff like that? Well, what you do is you build a board and you play with it. And maybe the backplane radio is the way to do it, because I could put a board with little transistor amplifier in it and with design so I could put things in and out just to check things out. Yeah, really, that's where I'm going. Learning how to use SNA again. I've got one. I haven't used it in a long time. Taking this crystal testing jig that Peter put together and building one of those. I could do that as a backplane thing. All these kinds of things, but as I can do some presentations, but I haven't really got a lot of topics that I can think of offhand. That
well, I think your idea of doing the overview or a rehash or whatever you want to call it of the Radio Fundamentals 101 is a perfect one to do.
Yeah, I want to do that because that's the way to learn, right?
Yeah. So that'll be a good one, and you can probably get several of them out of that.
Yeah, that's what I'm thinking. At the Mississauga Club years ago, we started doing how do HF transceivers work and stuff like that, and those kinds of things. So that's what the Fundamentals 101 is all about. So anyway, these are ideas. Also, learning how to not fry things. And I've spent a couple of days working on this. The audio amplifier. Actually have a breadboarded audio amplifier with an LM380, and it's taken a long time, but now I got something that works, and I can go on to do other things with that, add the preamps and stuff like that. So that's where I'm going right now.
Well, we all know how to let the smoke out, but none of us until today know how to put smoke back in the chip. But you told me today that you did do that, so you can.
Well, I did actually. I did.
You can probably do a presentation on how do you get the smoke back in the chip.
Well, this is my supposedly dead LM380. I had it on the board, and this is when I first started doing it, and it was really hot, like hot to touch. And I thought, oh boy, what have I done? And then I couldn't get the circuit working at all. So I replaced it with a new one, started over, and now I find this thing works. So I don't know. Weird. Anyway, so it's all about learning how to do things. Yeah.
Okay, sounds good, Michael. Okay, well, we're at just past 9 o'clock, so that's good. Again, I guess this is the last one of 2025. Great year for our presentations, and we could certainly use some guys for presentations in 2026. We've only got a couple of them scheduled in for January at the moment, so there's lots of room for everybody to, whatever project you're working on, just talk about it. So it doesn't have to be a full presentation. It could be a short, it could be a show and tell, those kinds of things. So I guess with that, we'll say everybody good night and have a good Christmas. And I'm sure we'll be chatting off and on before the new year, but we'll see you in January.
Yeah, thanks to you and Ken for sort of championing this thing and making it work week after week or month after month after month. It's been pretty good.
Well, three of us.
A lot of work for you guys to organize that.
No, three of us there, and with Eric presenting. So, I mean, if anybody wants to take a turn at presenting sometime, just say, hold your hand up.
So next meeting is Christmas Day, right? Orthodox Christmas Day.
Oh, there's always one in the group. What day is that?
For those of you that follow the
Merry Christmas. Take care.
calendar.
Yeah.
Merry Christmas all.
Yep.
Yeah. Have a good holiday. See you later.
All right, guys.
Merry Christmas.
Good night.
Bye.
You too, to all.
Thanks, Frank. You too.
Cheers, guys.